and which is this one. Now we have to length match this. How to do that? As I already told you, just click over this tab. So again, this is the single-ended connection, right? Click over this tab, and I'm just going to length match in this section. Just select it. Okay, so firstly we have to define, or we have to configure this, right? So press tab. Now out of these three, which one would be better here? We'll go for normal serpentine, right, which is accordion. And here just leave the steps as it is, and I'll go for let's go for default setup, and yeah, later we can reduce the tracks and everything. Let's see. So I have routed that like this. Now here you will see, if I'll again click on this one. Okay, so how again after this serpentine you'll see option. So how you can select that? You have to just click over here, either in the middle of those serpentine or on the track. Okay, so until you'll delete this serpentine, you can't able to select the track in this section. You can't select that. You can select in this section, but you can't select on this section after the cross section that we have selected, right? So first you have to delete that, then only then you can adjust those. So this is a kind of this thing creates problem when you have to adjust the length later, you know, when you realize, okay, you can further reduce the length. So what you have to do, you have to delete all those serpentines and then again reduce the track, then again go for length matching. So this is again a kind of closed loop which takes a lot of time. So what you have to do, you have to go to the manual, and here you have to fill the information like which length you want, what is the target length. So in our case the target length is 313, right? 313 mm, enter, right? And you'll see here the green marker. So that means to length match this outer track you needed only this section, right? Now what I'll do, I'll just select that, press tab and tab one more time. Okay, I don't know why it is not showing. Okay, so this track is, if I'll do that, you can see DDR4 and DDR1 DM2, those both have almost same length, right? Let's go for the another one, which is DDR-D2. So its actual length right now, it is, if I'll select that, it is 31.5. okay, and we have to go for 35.313. okay, so again select the serpentine, place on any section, let's suppose here. Okay, now go to the manual, and you can see it is already defined. So right now it is, you can see 32.3. we have to go for 35. That means, sorry, that means you have to route few more serpentines here, and when it will be 35, you can see it is, now it is 35.3. so you can see on this as well section, if I go to the routing, and press double tap, you can see, okay, it's not visible here, but yeah, when you see that here, so the scale is showing the length is 35.313, right? And this is D2, DDR0 D2. Yeah, this is the one, right? And you can see the length is matched here as well. For this, okay, this is also matched, right? Now we can go for the another one. So for another one, I'm going to use this section, okay, or you can use this section as well if you want. Okay, so let's see which one will be, or we can use multiple section like this. So again, you can't add serpentines on this section because this is very small, right? And you have to follow the width as well. Yeah, I forgot to tell you one more thing, sorry. So again, what will be this value? This is spacing. So again, this is the single ended, and as per LPDDR4, if you will go to the LPDDR4, you can see it should be at least twice the width, right? So what you can do, what is the width of this one? So it is 0.082 mm. Okay, you can just twice that, so it will be around 0.17, I guess. 0.082 into 2, yeah, it is around 0.164. okay, so that means this will be changed to 0.164 mm, right? And which is kind of good option for us, right? So this is kind of, you know, this needed less space as compared to the other one. So what you can do, okay, hold on, firstly delete this and just, you know, create some flat surface here. Now press tab, change it to 0.164 mm. okay, now route this and then click over the manual. So now it is fine. Okay, so we have this section as well that we can use for other routings. Okay, so this track is also kind of length matched. Let's go for another one. So here we don't need to again measure the length of each track. What we have to do, we have to just route the serpentine on a single straight section. Okay, and again this will be common for all the single ended for LPDDR4, right? Just click over the manual and here you'll see, okay, so this is only 33.21 mm, right? So you can't route further than that. Or what you can do?
I have a question.
Yeah, tell me.
Is it better to length match in the driver or the receiver?
I mean, right now I can't tell you. I mean, I never considered this point. Like either we have to like length match or route the serpentine at the receiver edge end or the driver end. Like how it will be different. I don't think it is like kind of different if you route those serpentine either on the receiver end or the driver end. Like you can like we can discuss that like how it would be different if I routed. So again, what is the receiver end? So these memories are the receiver end and this SOC is the driver end, right? Now like how it would be different if I route those here. Like what will change if I route those serpentines in this section? I don't think there will be any change here. And yeah, I've kind of heard this question before as well, or I don't know, there will be some changes, but yeah, I'll look into that and I'll discuss that on the group as well. Let's see what people think and what they say about this point, right? So right now I don't know the answer, but yeah, I'll look into that and I'll let you know.
Okay.
Yeah.
Thank you.
Yeah. Anyways, the board I have routed, I mean, it is working and tested. I don't see any problem there, and I've routed those serpentine like wherever I get the space to route those. But yeah, I'll look into that. Okay, so let's see another one, and yeah, just go for the serpentine on this. I guess this is again length matched. If you'll see, yeah, so it is 35.313. Let's check for this one. And yeah, let's go for that as well. So for that, route those, and you can see it's kind of, after setting up everything, you have to just create the space and you have to, you know, length match the tracks. So till here it is 34.99, right? That means we needed a few more in this section we can route those, right? Let's see. Yeah, some smaller ones. Let's see if we can go with this arc. Okay. Yeah, similarly you can go for this one. So yeah, this is the thing, and yeah, I'm just so there is no point to do that like or everything live, right? So I just want to discuss one more thing before leaving today's session, and I just wanted to read few things from the design guidelines, the document that we have for the layout and placement and for everything. So here what they did, they kind of given, you know, the sample you can not sample but some screenshots of the layout, right? For example, this plane, right? So that we will going to do after the discussion of ESPI. But yeah, as you can see, they have suggested that how we can section our plane, right? How, because see, I mean, this is again the common sense as well, because see, all these VDD logs on this section, right? And all the GPU pins on this section. So, I mean, this is the only way that we can section the plane, and all the VCC DDRs on this section, right? So this is a kind of mirrored image, or you can say rotated at 180 degree. But if you imagine that at, you know, by rotating that by 180 degree, you can see all the VCC DDR will be at the top, right? All the VDD logic at the bottom, and all these things will be kind of sectioned and going toward the PMIC, right? Because all the things are coming from PMIC. Yeah, there will be few buck converters, external buck converters as well that we are using. Yeah, so I just wanted you to just read this section. Okay, these are all the ground pin, right? So what is the right way to connect all the grounds with the internal layers? Like after finishing the routing of everything, what you have to do, you have to just place the via on each ground, not on the pad, but yeah, the section you'll see where we usually place vias, right? So for example, here we have ground, right? So what you can do, you can just, here we have multiple grounds, right? So you have to just place via for each of these grounds, and yeah, and you can follow the same dimension of the via. So that you can do after finishing the routing of everything, because see, when you do that right now, all this space will be covered, right? And you will not get enough space to route all those connections, right? I mean, you can do that by internal layers, but yeah, because see, all the grounds will be stitched together, right? So those will be going from so this is on the layer 1, right? So those will be going from layer 1 to all the grounds, like whatever the grounds are, layer 1 to layer 2, right? Or then it will go to layer ground 2, after that ground 3, right? So that means you can't route anything on those vias over those vias from layer 1. You're getting my point, right? Because there will be you know, plating of ground vias. I hope you got my point. So I just wanted you to just go through with that document, and that will kind of help you during the you know, all the assignments, especially the routing one, that was assignment number 9. Because see, this document is like it has 141 number of pages, but everything whatever given on the document is kind of very useful, right? So I just wanted to complete this section. I'm just going to note down the page number from where you can start. You don't need to go through with that, like antenna design and stuff, because for that we're going to follow the another design guidelines that is given on the Wi-Fi data sheet, that we'll see. Yeah, so start from this one, which is page number 120. Okay, and you can just go to here. Yeah, I guess that will be the last section, and this is page number 129. So, okay, so 80 to 129. I'm just going to note down that. So just go through with the theory or images, whatever they have given on the and images between, I guess, 82 to 123, right, of design guidelines. Okay, so yeah, this is it for today's session. And again, I just wanted to tell you the way you can do the length match. And yeah, by tomorrow I'll share the completed assignment, and that will be for your reference. So you can just just go for your practice. And again, yeah, I mean, you have to do that by your own. Let me know in case of any thing required from my end. And yeah, that's it. Any doubt till here, people? So my plan is like from the beginning we are kind of more focused toward the designing and toward the layout and everything. I just wanted to discuss the things from the simulation end or the signal integrity, because see, you can't lay out something if you can't able to visualize the SI issues, right? So I just wanted to discuss those points, and most of those points will be from the Eric's course, which I guess I have taken, and I've already shared the 3 months free subscription on my LinkedIn. So that was from their end. And yeah, so their marketing team kind of contacted me and given that, so I can share those with my students and the people I know. So I hope you already subscribed that the 3-month course, and you can start from the advanced gigabit channel design. Skip the first one, which is the essential principle for signal integrity, because I'm going to discuss that on next session. Okay, so that is it from my end, and see you people on the next session. Okay.